It's our favourite type of electronics. It's dead electronics, particularly with hot melty bits and a real electronic stink. So this is a passive infrared detector, typical type you might find in the garden. And it comes with this story. Hi Clive, this PIR operated a water feature. The water feature stopped, found the mains 3 amp fuse blown in the connection unit. I put a new fuse in, looked at PIR and it lit up in the top left corner. I marked in purple, so it was actually glowing in here. Arcing, presumably. It lasted about 6 seconds in total. Obviously it was something inside burning, which can't see, but on the top has melted. Okay, let's explore. So this is a typical detector. It's got 3 wires, brown, blue and red. Usually brown, blue are live and neutral, and red is normally the switched feed. Let's just lop these right off and get them out of the way. I shall reduce the size of the unit a bit. So off go those, because I don't think this is getting used again. It looks as though it's gone smoky. It's also fetching a shade of black, which is never terribly convenient for visible things. Oh. So the first thing I'm noticing is that normally there'd be a couple of screws holding the bottom here on. Oh, it is stinking so much. If this was fitted with smell-o-vision, you'd be getting this right now because this is stinking. Oh, this is glued together. Let's get the vice of knowledge in. And we'll squeeze it till it pops. So I shall try squeezing the base. Not that I'm trying to keep anything intact, because let's face it, it's dead. Oh, that is actually quite tightly together. Right. I know what tool to use here. One moment, please. Pipe grips. They're so destructive. Let's put it in here and give it a squeeze. That's making crunchy noises. These will open most things destructively. I mean, let's face it, it's not going back together again, is it? Oh, that sounded reassuring in a sort of destructive way. Let's stab a screwdriver into it without stabbing a screwdriver into myself. This is not always guaranteed. Try and open this up a little tad more. Oh, this looks promising. So the inside is coated with... Oh, the smell. The smell is absolutely terrible. It is stinking. Now, okay. It's the relay. Right, okay, I have to get you a closer look at this relay. One moment, please. Right. This is complex. Because the fault could have started in 3 places, but I think it started in the relay down to the fact that there wasn't enough clearance in this contact. This is a side view of the relay. It's very, very burnt. The side is physically burnt off from the little fluffy fibrous stuff here. I'd say it's probably glass reinforced plastic. The relay has a little contact, bounces up and down here, and that is this bit here. It goes up, touches the contact here, which wasn't in use. And it also has another contact, which was the normally closed the normally open contact, the one that would actually bridge when it comes down. And it's here, and I get the feeling that it's arced between the common contact and the normally closed contact. And that arcing has been sustained even when the relay's possibly been off, because it's just not been given enough clearance to break the load. There is a snubber network. I'll show you the remnants of the snubber network as well. Well, let's take a look. That's the capacitor. It was right next to the relay. It's very hard to say which went first, but this one has a little adorable little hole in the side where it's obviously shot a flame out. Whether it was this that set fire to the relay or vice versa is very hard to say. It's one of these things that if I'd got one that had just started flickering or going wrong, I would have been able to tell a lot more. But this is toast, as you may see. I shall put this out the way. It's also extremely stinky because that plastic is very burnt and crusty. Right, the circuit board. Quick summary of the circuit board, and we'll marvel at their token gesture anti-tracking slot. There's the token gesture anti-tracking slot. It doesn't really do an awful lot. Let's zoom down on this a bit. So here's the front of the circuit board, and here is the back of the circuit board, just in case you want to trace things out yourself. It's all a bit black down here. Things worthy of note before we go any further. There is the token gesture anti-tracking slot between live and the coil in this instance here, plus also the track-wise, it's the live and neutral. But look here, they've actually just run it right next to the neutral's just passed right next to the live with a very thin track that has done its best to blow up. But the neutral continues along, and it's quite interesting their use here, why they've continued neutral down here, because in reality, they could have done it differently, but it's actually complicated by LED loads. That's not clearing things up, is it? Let us move that out the way. But there's the snubber network, by the way. A resistor of unknown value because it's chromated, and the capacitor, which is 22 nanofarad, which is quite low for a snubber network. Here's the circuitry. A quick summary of the circuitry itself: a capacitive dropper, a bridge rectifier underneath, a Zener diode, probably 24 volt clamp, smoothing capacitor, voltage regulator, feed a BISS0001 generic passive infrared chip, which has the light sensing facility and timing with these capacitors, and also the actual passive infrared sensor, which just puts a low-level signal out that gets amplified by this chip, and it looks for undulations as people walk by, and then triggers, when it reaches a threshold, it triggers a timer. Everything is built into this chip. By changing component values, you can tweak and adjust to your heart's content. The unit turns on, the chip turns on what the smoking remnants here with this transistor. 10k resistor in series of the base of this transistor, and then it switches the coil. This little diode here is across the coil to protect that transistor. The relay. Here's the other bit where it could have failed. It's possibly the heat that came down this track. They've the other normally closed contact, they've just cut it off in the bottom of the relay. Switch just sat on top of the other side of the circuit board. But this area here has a very obvious sign of tracking. Let me just zoom into this bit, because this is the bit we're looking at now. I shall make sure I'm still focused on that. This is where it all goes wrong, but suddenly it's not in focus. So here is the feed to the middle pin. That's the common contact of this relay, and here is the normally open one that then feeds over to the output. And there's also that little snubber network with a capacitor from here to here, and then the smoke remains of a resistor over to there with tracks blowing off and everything. So here's the other possibilities that could have failed. We've already had the relay could have burnt up inside. I think that's a prime suspect. We've already had the snubber network capacitor could have failed, but it's in series with this resistor, and that should theoretically have kind of blown clear like a fuse. But now we've got the neutral that was brought over for that snubber network is right next to the switch live, and there is very obvious signs of the pitting and etching into the circuit board that's been tracking. So that while that was on, it may have actually just continued to burn, particularly if humidity got involved, but then finally just actually flashed over. And when it flashes over, that's when it will blow the fuse. Sometimes it will just arc and fizz for ages before doing that. And sometimes you put the fuse in, it will have blown itself clear, and it will just start fizzing and arcing in the background again until it flashes over later on. That happens a lot. So the snubber network, let me just zoom back out again, and we'll talk about the snubber network. I shall bring in a notepad. Quite often when you have a relay contact, let's just draw it like this. Quite often you will have a snubber network, which is a capacitor and a resistor across that. And the point of that is that this would typically be 100 ohm, and this would be 100 nanofarad, is very typical. You actually get dedicated snubber networks. I was just looking for one here, lying next to the bench. No, it's not going to be there. It's not going to be there when I need it. I kind of want it. Right, one moment, please. A snubber network. This one is 220 nanofarad and 100 ohm. It's just a capacitor like this inside in series with a resistor, all just built into the one package. And this is normally wired across contacts and contactors. And here's the idea. When this contactor, when this contact opens, sometimes you get a little bit of an arc occurs between the two contacts. And because the capacitor has it happily, with the higher frequencies, it'll actually pass them easier. It effectively provides an alternative path for that, and it takes a lot of the current away and lets that arc extinguish. The resistor is here to limit the amount of current that can flow through the capacitor effectively in that way. Also, it's to limit having a capacitor across the contacts, because otherwise it can cause pitting, so it limits the current. What they've actually done, supposing this is live and it was going out to the load and there was neutral going straight out to the load, neutral, load live. What they've done is they've put that capacitor across there instead. And the reason they've done that is because if you have a standard snubber network across a contact switching an LED lamp, that 100 nanofarad capacitor will easily pass enough current to keep that lamp glowing or make it start pulsing. So that's why they can't really do that with very sensitive loads like compact fluorescence and LEDs. So that's why they've put that there. Other things worthy of note. Quite often, if you have a circuit board that's designed properly and it's got the relay on the board to switch a load to an output, you'll often find that there's a little thermal fuse mounted right up next to the relay, sometimes actually stuck onto the side of the case. The reason for that is that when something like this happens, let me just grab the charred remnants of that. When something like this happens, and the case starts burning up because the contacts are arcing inside or just make a bad connection resulting in the arcing, this fuse will break the circuit. And if that's, say, for instance, leading to the common connection in here, then it just kills that part of the circuitry. Sometimes it just kills the whole unit completely when that thermal fuse goes. That's when things are properly designed. This design is so perplexing because it looks like someone's copied a design or just based on a standard design, but their grasp of the vicinity of things like neutral and live is just not there. They've not had that understanding. Likewise, the relay it just seems so small. A lot of stuff you get from the grey imports from eBay, you'll find these relays are not rated even for, in the case of the UK, 240 volts. They're only rated for about 125 volts. And the current ratings are always ambitious. You know, they say things like this can switch 10 amps. In reality, it's not going to switch 10 amps in the case of some of the modules. But interesting. So without actually catching it earlier, I can't tell if the fault originated in the relay. I'm going to say that I think it is arcing the relay. Or if it's the little snubber capacitor, which has kind of blown out the side here and cracked. So it's obviously been pretty unhappy, but then it's been next to something that was on fire. Or this tracking down here, but this tracking could have been initiated by the heat from this pin getting red hot, causing heat to travel across and burning the actual circuit board itself. The underside of that coil is pretty black. The whole lot's been going up. But that's fascinating. Interesting stuff. It's always worth looking at designs like this and how they've failed, because it shows you what can go wrong. In this case, just for that tiny bit of extra space, that little thermal fuse, even if they'd butted the thermal fuse up the end here and moved the snubber elsewhere, that could have actually saved this whole thing from happening. But there we go. An autopsy on a completely smoked passive infrared detector.